So hello guys, today we are going to do a Leetcode question, that is Leetcode daily problem. It says majority element by the title. Okay, so what does majority element question has to say to us? Let us start by reading the problem statement and then we'll move towards the problem understanding, what the problem is saying. Okay, so let me first try to read it. What does it say? I'll start by first reading it. So it is given that given an array nums of size n, return the majority element. Given an array nums of size n, return the majority element. Okay, but what does majority element means? Okay, so LeetCode is explicitly specifying that what does the majority element means. So it means that the majority element is the element that appears more than n by 2 times. You may assume that the majority element may always exist in the array. Okay, so LeetCode is saying to us that majority element, I suppose that the majority element is that element that occurs more than n by 2 times in the array. And it is saying that in an array, in my question, a majority element will always occur. A majority element would also always occur. More than n by 2 times means more than n by 2 times means if n is the size of the array, n is the size of array, then majority element occurrence will be greater than n by 2 times. Suppose if my array is 1 1 2 1. Okay, so what is the size of the array here? What is the size of the array here? I'll see that the size of the array is 4. The size of the array is 4. So my majority element should occur 4 by 2 greater than 4 by 2 times. That means my majority element should occur greater than 2 times. Greater than 2 times. Greater than 2 times. So what I can see is what is the element that occurs greater than 2 times here? 1, 1 and 1. I see that 1 occurs more than 2 times. The occurrence of 1 is more than 2. The occurrence of 1 is more than 2. So 1 occurs 3 times here. 1 occurs 3 times here and 3 is greater than 2. So my answer is gonna be 1 in this case. Answer is gonna be 1 in this case. 1 in this case. 1 in this case. Okay, 1 in this case. That specifically means, so now you must have understood the problem, that what the problem is trying to say, the element that has frequency greater than n by 2 times is my answer. That has frequency greater than n by 2 times is my answer. So what can be the problem statement is clear. I hope the problem statement is clear. So I'll move towards the brute force solution. Brute force approach. Okay, we'll try to think and we'll move towards the optimal one. We'll try to think how we are thinking and we'll try to move towards the optimal one. Okay, I'll take this test case. 2 2 1 1 1 2 2. 2 2 1 1 1 2 2. Okay, so what can be my brute approach? Okay, so I'll take a small example. Okay, I'll take a small example for you to understand. Suppose I have this 3 2 and 3. 3 2 and 3. So and if I'll just record my n. Okay, I'll just record my n. My n is 3. My n is 3. So my n is 3. If I divide n by 2, so this becomes 3 by 2, and I know that 3 by 2 gives us the floor of the value. That means 1.5 floor is equal to 1. So my answer's frequency should be greater than 1. Should be greater than 1. So I'll just make two loops. And from one loop I'll start iterating from here. I'll go towards the last, and I'll take this element as my element. I'll take this element as my element. I'll store it in an element variable. I'll store it in an element variable. Okay. And what I can say is elements variable, and what I can say is you will just, if you encounter any more threes, here my count is gonna be 1. Okay, If you encounter any more threes in the array, if you encounter any more threes in the array, so one index I would be here, and I'll iterate j through here, from here to the end of the array. I'll iterate j from starting to the end of the array. And if you encounter any element that is, if you encounter any element that is the same as nums of I, that is the enter position of my first element, starting of the element, then just increase my count. Then just increase my count. Okay, then just increase my count. If my count becomes greater than n by 2, if my count becomes greater than 1 by 2, just return me the answer. Return me that element. Just return me that element. Okay, I hope you understood it. Okay, what I'm trying to say, if I record the, if I start from here, if I start from 3, I'll start from 3, my I is here, my j starts from here, my count is currently 0, my j is pointing here, so I'll increment the count, it is equal to 3. Okay, my element value equal to 3, so I'll compare it with the value at nums of j. I'll compare it with the value at nums of j. Okay, so I'll move here, I'll check here that my, if my nums of j is equal to element, if my nums of j is equal to element, I'll just increment the count. So my count becomes 1. Okay, I'll my pointer, my j pointer moves here, and it says that is nums of j equal to element, is 2 equal to 3? No. So I'll just increment my counter. And if I move here, I'll move my j here. So I see that nums of j, now nums of j equal to my element. So I'll just increase the count. So now my count becomes 2. And this count is obviously greater than n by 2 because 2 is greater than 1. So in this case, my answer 3 is returned. As we can see also, 3 is my majority element in this array. Okay, so I'll just iterate, I'll just make two loops, and I'll fix my element, fix my element at the first position, and then I'll traverse through the full loop, and I'll increase my element occurrences. At the current loop. If my element occurrences becomes greater than n by 2, I'll just return that element. So I hope you guys understood this. So what is gonna be the time complexity of this question? What is gonna be the time complexity? Two loops are there. Suppose one goes from I is equal to 0 to j to n minus 1, and other goes to j is equal to 0 to n minus 1, and they both are nested. In one another. Okay, so my time complexity becomes O of n square. And what is my space complexity? As I'm not using any extra space, so my space complexity becomes stays O of 1. Okay, stays O of 1. Okay, you got the way, right? If I try to summarize it, if 1 to 1 is my array, 1 to 1 1 is my array, I see that n is 4, so n by 2 is equal to 2. So I have to get an element that has frequency greater than 2. I can easily see that 1 has a frequency of 3, and 3 is greater than 2. So I'll return my answer 1 as the final answer. Okay, so I'll return 1 as the final answer. So I'll just return 1. Okay, and how I'll get that this is my final answer? I'll just make the count is equal to 1 here and count is equal to 1 here by traversal. If I get any more ones, I'll just increment my count. And if at any point of time my count becomes greater than n by 2, then if count becomes greater than, so I'll return that element. Remember that whenever switching the first position, whenever I am switching the element, I have to make the count equal to 0 again. Because if 1 to 1 is there and I'll record the frequency of this as 1, and after I come here I record the frequency as 1, my count becomes 2. So when if this is greater than, if this is greater than, this is greater than 1, it's perfectly all right. But if it is not the majority element, when I'm coming to this position, when I am coming to this position, I want to make sure that my count is 0. I want to make sure that my count is 0. Okay, so when I come here, my count should be 0, so that this, so that the count can now contains the frequency, so that the count can now contain the frequency of 2. Okay, it's just simple variable, same variable we are using. So in one variable we are storing basically a count, so O of 1 becomes my space complexity in this case. Okay, now if I come to the optimal, I'll come to the better solution first. I'll come to the better solution. Okay, now I'll use the second test case. I'll use the second test case, and then 2 2. What I say is, if I want, I'll first record the length 1 2 3 4 5 6 7. So 7 elements are there. 7 by 2 is equal to 3. 7 by 2 is equal to 3. 3.5 basically, and we get the floor of the value, so it becomes 3. It becomes 3. So I have to get a frequency element, an element of frequency greater than 3. I have to get an element of frequency greater than 3. So if I want to get a frequency of the element, what is my best data structure? Best data structure. What is my best data structure that could store frequencies for me? That could store frequencies for me. Yes. What is that data structure? What is that data structure? Obviously, unordered map. Unordered map. So I'll make an unordered map int that will store the element as well as the frequency of that element. I'll store the element as well as the frequency of that element. Okay. And I say that during traversal, I'll make one traversal to store. I'll make one traversal. I'll make a map. I'll make a map. Okay. My frequency should be greater than 3. This is my condition, that my frequency should be greater than 3. Whenever I get this condition, I'll quit. I'll quit. Okay. So if I try to move here, if I try to move here, if I try to move here, okay. So I am at currently index 2. I am currently at index 2. What is my frequency of 2 in the map currently? What is the frequency of 2 in my map currently? 0. So what I do is I'll just come here and increment my count. Okay, 2 becomes greater than 1. And I'll check if this frequency is greater than 3. No, this frequency is not greater than 3. Okay, I'll move forward. I'll move forward. What I get 2, I'll just map this 2 to my map. Okay, and I'll check if it is already present in the map. If the value is already present in the map, if the value is already present in the map, I'll just increment it. I'll just increment it. So my 2 becomes 1, 2. 2 becomes 2. I'll move to the next position. I'll move to the next position now. I'll move to the next position. So I move here. I move at this position. I move at this position now. Okay. So I checked whether 1 is present. Whether 1 is present in my map. No, it is not present in my map. So I'll store 1 and I'll store the frequency of 1. So it is also 1. So 1 becomes 1 frequency. So is 1 greater than 3? No. Still not getting my answer. Okay, I'll move forward. Still not getting my answer. Okay, I'll move forward. So I'll go again. I'll get 1. I check that whether it's present in the map. Yes, it is present in the map. Yes, it is present in the map. What should I do? I'll just increase the frequency of 1. I'll just increase the frequency of 1. So I'll mark it 2. I'll mark it 2. Okay. I'll mark it 2. I'll move forward. Is 2 greater than 3? No. Is 2 greater than 3? Is this 2 greater than 3? No. So I'll move forward. I'll move forward. I'll now come to here. I'll now come here and I'll see is one present in the map? Yes, 1 is present in the map. What is its frequency? 2. Increase the frequency. Increase the frequency. So I'll just increase the frequency and I'll get 3. Is 3 greater than 3? No, 3 is not greater than 3. 3 is equal to 3, but 3 is not greater than 3. Okay, fine. I'll move forward. Then I'll move forward. I'll move to 2. I'll move to 2 and I'll check if 2 is present in my map. Yes, 2 is present in my map. So just increase the frequency count. I'll just increase the frequency count. What my frequency count now becomes is 3. 2 is accompanied by 3. So is 3 greater than 3? No, still no. I'm not getting my element. I'm not getting my majority element. Okay, I'll move forward. I'll move forward. I'll go to 2. I'll check if 2 is present in my map. Yes, 2 is present. What I'll do, I'll increase its frequency. I'll get 4. I'll get 4. Is 4 greater than 3? Yes. Is 4 greater than 3? Yes. So, if my 4 is greater than 3, that is 4 is my majority element in the array. 4 is my majority element in the array. If 4 is my majority element, I'll break through all the loops. I'll break through all the loops and then I'll return 2 as my answer. Return 2 as my answer. I'll return 2 as my answer. So 2 as my answer is returned in this case. Okay, so we are just doing nothing. We are storing all the frequencies of all the elements, and whenever my element's frequency becomes greater than n by 2, I'll just break the loop. I'll just break the loop. I'll just break the loop. I'll just break the loop, and I'll declare that particular key as my answer. That particular key as my answer. Okay, if I take that second test case, if I take the second test case, same works for it. 3 2 3. Okay, 3 2 3, and I'll make a map. I'll store 3 2 and 2 1. Okay, so as soon as n is equal to 3, n by 2 is equal to 1. Okay, so as 2 becomes greater than 1, 2 becomes greater than 1, so that means that this is my answer, this is my answer, this is my answer. So 3 will be returned. So very simple approach, very simple approach. This was the approach using map. As we need to store frequency, very intuitive, because we need to store frequency. I can easily see as I want to store frequency, I'll just easily store the frequency, and if my frequency count is greater than n by 2, just just return return that element. Okay, okay, fine, okay, fine. I hope you get it. Now, if I talk about the time complexity, what is my time complexity of this question? As I'm traversing only once, as you can see, I have moved from here to here only once. So what my time complexity is? O of n, time complexity. And what is my space complexity? As I'm using an unordered map, so my space complexity also becomes O of n. Okay, but is there any better approach than this? Is there any optimal approach? Yes, there do exist an optimal approach. I have broken down the time complexity from O of n squared to O of n, but the space complexity has increased. Space complexity has now increased. It has become O of n. Can I further optimize this? Can I do this in O of n time, and O of one space, and O of one space? So I'll just try to optimize this. I'll do it in O of n time. I'll just do it in O of n time and O of one space. Can I do this? I think, do you think it's difficult? No, it's not at all difficult. It's just logical how to do it. I'll just try to figure my optimal approach. I'll take the test case. I'll take the second test case. Okay. 2, 2, 1, 1, 1, 2, 2. Okay. So if I tell you what the question is saying, if we get to the question again, what my question is saying, the majority element is the element that appears more than n by 2 times. More than n by 2 times, more than n by 2 times means that it should be present. If this is my array, this is my array, suppose it contains six elements. So the majority of my element, the majority element should contain more than half part, of the array, should occupy more than half part of the array, right? No confusion, right? Because this is n by 2, 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 n is equal to 6. Okay, so my majority element should cover more than n by 2 part of the array, more than n by 2 part of the array. That is given in the question. Yes, bhaiya, we are given in the question. Okay, so we are given this in the question. Okay, I understand. Okay, so if I make a condition, that suppose 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 there are plus one, just positives and negatives present in my array, positives and negative present in my array, positive, 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 and then negative, negative, negative. Okay, positive, 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 negative, negative. As you can see, the length of the array is 6. As you can see, the length of the array is 6. Now, what if I say, if I want to cancel this out, you know that positives and negatives cancel out each other. Positives and negatives cancel out each other. So, this positive cancels with this negative. Okay, this positive cancels with this negative. This positive, or let us understand this way. Let us understand this way. If there are three positives and three negatives, I'll just add up all the positives. I'll add this positive. Okay, I'll add this positive. So two positives. I'll just add three this positive also. So there become three positives, and three positives can be cut down by three positives can be cut down by three negatives. Three positives can be cut down by three negatives. So my overall answer becomes 0. My overall answer becomes 0. So there can no such element be in this array. There can no such element be in this array that can be the majority element. That can be the majority element, because if I say that, what if plus or minus, what is coming as majority in this array? Majority in this array. If my plus and minus are present in the same amount, same count, if they have the same count, then there exists no majority element. But suppose if I want to make it such that, I want one majority element to exist. I want one majority element to exist. What should be my condition? If I modify the array? If I say that I want to modify this array only such that it becomes a majority, such that one majority element occurs. No matter it is plus or minus. Okay, so what do you say? Yeah, I have two options. I'll add a positive. I'll add a positive, or I'll add a negative, So that can be my majority array. So I'll do only one operation. Suppose if I add a positive here, so this positive is the one. This positive, hear me clearly. Okay, no confusion should be there. This positive is the one that is holding up the sum to be positive. Because without this, the sum would be negative. Clear? If there are four elements, and if I say what is the sum of these, or plus minus minus both become 0. So what I can do is, suppose if I add one more plus to this, so this plus, due to this plus, my overall sum is positive. If my overall sum is positive, that is because of this element. If this element doesn't exist, then my majority element wouldn't be present in the array, because this element is the only one that makes the sum positive. Okay, This element is the only one that makes the sum positive. Okay, okay. And now if I relate it to the question, so if I take this test case, if I take this test case that is given to us, 2 2 1 1 1 2 2. Okay, 2 2 1 1 1 2 2. Okay, and what I say is if I make this, if I make my first element as a positive one, like I told you this, right? Ki plus 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 and minus 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 would give me a sum 0. Okay, I say that whatever is my element's position, whatever is my element variable, that will act as a positive. If I consider this analogy, that will act as my positive, and all the other numbers would act as negative, okay. So if I start traversing from here, if I start traversing from this, okay, so here comes my element and my counter. I'll make a counter is equal to 0 for now. Okay, if my counter is 0, I'll just increment my counter. And I'll assign my element to the first value. I'll assign the element to this value that I'm currently on. So my element value becomes equal to nums of I. That is my current value. Okay, I'll do this and just move forward. Now for now, my count is currently 1. That is a positive number. That means my count is something that is keeping my sum positive. My element is something that is keeping my count positive as of now. Okay, so if I move forward, I get to 2. So 2 is the element that my current element is. That I check the value with my element, if my element variable, and I see that it is something that can increase my count. So my count becomes 2. Now, if I see my first element that I assigned when my count was 0, is still the one that is keeping up the count positive. Is still the one that is keeping up the count positive. If I move forward, if I move forward to 1, okay. So 1 acts as a negative number that will decrement my count. So my count becomes 1. My count becomes 1. My count was 2. My count becomes 1. I move forward. To this position. Okay. So now now the element is 1. It is also acting as a negative number. That is also acting as a negative. So this will decrement my count. So my count will become 0. So if my count becomes 0, that means till this range, from this range to this range, this is not visible, right? From this range to this range, from this range to this range, it contains equal number of positives and equal number of negatives. That is, till now my element my element is not able to make the sum positive more positive. It is going to 0. It going to 0 means equal number of positives and equal number of negatives are present. Okay, I'll move to the next person, and I'll do the thing again that I did on when the count was 0. When the count was 0, what I did was I assigned my element to the current value. So for now, if I consider this 2 2 1 1 1 2 2, so now my element becomes 1. I am currently at this position. And my element becomes 1, and my count also becomes 1, because I am counting this number, right? I am counting this plus, right? So my element would always be a positive, and all the other elements would be negative. So my 1 is currently the element that is keeping up my sum positive. So if I move forward, what I get is 2. 2 acts as a negative number. So 1 minus 1 becomes 0. So my count becomes 0 as of now. My count becomes 0. if my count becomes zero, if my count becomes zero, if my count becomes zero, then I'll do move to the next position, and what I did for count is equal to zero, I'll do it again. I'll do it again. I'll reassign my element to 2. I'll reassign my element to 2. Okay, so 2 is there that is keeping up, and I'll increment my count. So till now what we infer is 2 is the current element, 2 is the element for now, 2 is the element for now that is keeping up, my sum, my overall value positive, overall value positive. So after this the loop ends. That means 2 was the only element, 2 was the only element that was able to keep my count up, that was able to keep my counter positive. Okay, that was able to keep my counter positive, because all the positives and all the negatives were cancelled before this, were cancelled before this position. And at this position, I encounter a element that is keeping up the sum as positive, because from this to this it becomes 0. It becomes 0, positive, negative, positive, negative, positive, negative. And this is the one that is keeping up the count positive, that is keeping up the count positive. So this is my answer, this should be my answer. Now bhaiya, why we didn't want to, if I am checking for this, and I'm just moving simply and not checking. Suppose I am here and my count becomes 0 here, my count becomes 0 here, and I'm simply starting from here. Why I'm not checking all these elements? Why I'm not checking all these elements? Suppose I'll explain it to you. Okay, when this was increasing, when 2 was the reason for my increase and 1 was the reason for my decrease, or any other number was the reason for my decrease, that means 2 and 1s were present in the same quantity, were present in the same quantity. Okay, if I say that three positives are present, and some number of negatives are present, that is making up my sum 0, that is making up my sum 0. So if I ask you how many negatives were present, so I say that 3 positives were present and my total sum is 0. So how can you say that, how can it become 0? It can become 0 by 3 negatives, by 3 negatives. So 3 positive minus 3 negatives, 3 positive plus 3 negatives can only give me a sum 0. So if this one has contributed, if this one has contributed in my sum to decrease, I'll not count it again. I'll not count it again. Okay. If I see for this example, I'll see for the second test case. If I see for the second test case 3 to 3, I'll see for the second test case 3 to 3. I'm here, I make my element as 3, I'll make my count as 1. Okay, now 3 acts as my positive element. I'll move here, count is 1. To any other number acts as my negative element, so 1 minus 1 becomes 0. Okay, I'll reassign the element, is equal to 2 it becomes. I'll make the count as 1, Okay, so I'll make the count as 1. Now E is equal to 2, so what is the reason of my decrease? What is the reason number of my decrease? All the numbers, other numbers other than 2, act as the decreasing numbers, So if I go to 3, what my sum becomes, no, if I go to 2, suppose we go to 2, okay, so this is the reason of decrease. C becomes 0, I'll move forward. Now here my C is 0, what I'll do again is, I'll make the element equal to 3 and my C equal to 1, and at next position the loop ends, So what was the last number, that was able to keep up my sum positive? That was 3. that was 3. So in a combination of positives and negatives, if there is someone who can keep me positive, I'll return this as an answer. Okay, because all the positives and negatives in equal amount will get cancelled, and there will be one element that will be making the sum greater. Okay, so this is my analogy of this question. I'll just code it for you. Int element and count is equal to 0 for, I'll just traverse the whole array. If I see that my count has become 0, then what I'll do? I'll just reassign my element. The current element, I'll make my count 1. If my array element is equal to if my current element is equal to the element that I chose before when my count was 0, so I'll just increment my count. Else in any case, I'll decrement my count. Okay, and I'll simply return my element. Because this element is the last number. That could keep my sum positive. Okay, that could keep my sum positive. That means if 3 plus are there, 3 minus are there, then this extra positive was the only reason. That kept my sum positive. So if I try to run it, okay, it ran. I'll try to submit it. Submitted, yes. Okay, so this is the overall approach that I wanted to discuss. Now if I see the time complexity of this solution, so as I'm running a loop only once, my time complexity becomes O of n. And what about my space complexity? As I'm not using any extra space, I'm just using the variables, so my space complexity becomes O of 1. So see, I solved it in time complexity O of n and space O of 1. And what is the other name for this algorithm? Do you know there is a name for this algorithm? The optimal solution that we discuss right away is known as Moore's voting algorithm. So I just explained you an algorithm without even knowing that this was an algorithm, and explained it in the form of an intuition. I hope you got it. Okay, so this was the overall optimal solution that we could get of this question. Okay, if you have any doubts regarding this question, then just comment them, and if you like the video, do share, subscribe, and okay, have a good day. Bye bye.